Okay, Namaskar, my physics learning friends. Today we will discuss a few things related to this shear force. Actually, in our last video, we have discussed about the axial forces. What exactly the axial force is? That is basically it works along the centroidal axis, and the shear force that will also we have discussed that this particular force will be applied on the perpendicular plane which is perpendicular to the centroidal axis. So let's say here few more things about the shear force. The shear force is an unbalanced vertical force on one side, either the left or right section of a beam. It is the sum of all the normal forces on one side of the section. Always remember that a force at a section means a force of a certain magnitude acting at that point. If a particular point is considered and the value of force we need to find out, so that is simply the magnitude of that force acting at that point. Whereas the shear force at a section means the sum of all the forces on one side of this section. Here in this figure A, we have considered a simply supported beam or a member which is supported at 2 points. Here it is the first point, we can say this point A, let's say it's A point, and this point, let's say it's B point. So on the 2 points the beam is supported and it carries four loads. That's here it is W1, W2, W3 and W4. These are the four loads which are acting on that member of the beam or the member. The reactions at the supports are R1 and R2, which is displayed here. These are the R1 and R2 reactions on the member. Now if the beam is imagined to cut at a section XX, let's say if here from here we will cut the beam. So now you will see in the figure B. So this is the XX section from where the beam is cut in two parts. The resultant of all the forces or the loads to the left of the section is F. We are assuming that it is an upward force. It may be the downward force, but here we are assuming that it is an upward force in this first section. If this is the A and B beam and the beam is cut at this point, so we have this particular section and this particular section. So this from this XX section, from this left side, we are assuming that the load that is working, the force that is working on this particular section, it is working in upward direction. Also the beam is in equilibrium. Okay, if the beam is in equilibrium, then the resultant of the forces to the right of the XX cross section, from this XX section, it must also be F downward. So in this section it is F downward, in this section it is F upward. So the F is known as the shear or the shear force. Okay, so this F will represent the sum of all the forces acting on this XX section of the beam. So by this you may understand what exactly the shear force is. So hopefully you are getting this about the shear force. Okay, by taking an example of a beam AB which is cut from this particular section, and the load which are applied over there, those are also displayed in figure A and in figure B. So figure A we have cut at this particular section, so the diagram will be changed like this, and here we may say the force F, that is the shearing force. Thank you. Thanks for watching me.